Hey class, welcome to Introductory Psychology. This is the first chapter of the King text. So hopefully you have the textbook, maybe a physical or a digital copy, however you want. This lecture video is not necessarily meant to replace the video or the lecture, the text, excuse me, but it's meant to supplement it. Some people really like to not only read the text, but also maybe hear it and talked about while it's, on a kind of a visual PowerPoint like this. So again, don't replace reading the King textbook, but if you need a supplemental resource, this is a great way to go. So this chapter, we're going to be covering a few different things. It is the first chapter of the textbook, a psychology textbook. So we'll start by defining what psychology is. We'll look at the approaches at which psychologists work to collect data, particularly diving into the scientific method, maybe something you've heard ad nauseum by now, but we'll explore that again. We'll then explore under that umbrella of the scientific method. We'll look at the different types of research that psychologists conduct. We'll also talk about the settings in which they conduct research and the difference between samples and populations in terms of using individuals to participate in their research. And then finally, we'll wrap up with a discussion on the ethics of conducting research, both with human and non-human participants. So a lot kind of going on here. Some psych courses and textbooks will kind of break these into two different chapters. The King book brings them into nice one kind of succinct chapter, which I kind of like. So first, kind of the first half of the chapter is more about a history of psychology, kind of where it's coming from, where it's going. Second half will be more about the research methodology. So we're going to be talking about, psychology for the next, conceivable. I think we have 14 chapters, 16 weeks typically, or how these courses are structured. Some questions you might want to consider asking yourself, and you can pause the video and kind of answer these out loud if you'd like. How many of you have an acquaintance who is a psychologist? Chances are you probably know somebody who works in the field of psychology, maybe directly or indirectly, or, maybe it's a parent or a family member or a neighbor or a friend or somebody, but it's such a growing field that chances are we probably have encountered people who are psychologists who work in psychology, maybe more often than you think. So even if you don't necessarily know somebody who is a psychologist, though, you probably have some ideas about what psychology is that you bring to the table. Maybe those are things based on pop culture, movies, TV shows, books, things that you've kind of encountered before. Maybe you took a psychology class previously. I know some high schools, for example, offer psychology courses. I used to teach AP and on-level high school psychology. So you get a lot of students who, maybe they took on-level or AP and they take it again, introductory in college or some way or another. So you might have had some exposure one way or another. So you might want to think about, really stop and maybe pause the video now and think about, where did your ideas about psychology come from? And hopefully, I'm hoping this course will maybe add to, maybe you already have a good idea about what psychology is, but I hope this course will help you kind of better understand it, maybe flesh out your own understanding even deeper. So what does it mean? We're going to be talking about psychology. What the heck does it mean? What is it? I think a lot of people associate psychology with things like the study of mental illness, and that certainly is an aspect of psychology, or people think about in terms of like analyzing people or studying and trying to understand people. And those are certainly big parts of what psychology studies, but the bigger, more broader umbrella is psychology is the scientific study of behavior and mental processes. And we can really break that down even further. So for example, when we say it's the scientific study, we're talking about a systematic approach of methods for trying to answer questions related to phenomena of behavior and mental processes. So let's unpack that further. What the heck do we mean by behavior? That's really anything that can be directly observed, things that we can directly measure. So, right now you can directly see what I'm doing on this screen, moving my hands and arms, I'm talking, I'm presenting. Those are things that are directly observable by you, watching this video right now. Mental processes are a little more difficult to necessarily see because these things include thoughts, feelings, motives, planning, decision-making, all kinds of things that are basically happening between the ears. And for a long part of psychology's history, there was a pretty large, big debate about, should we focus specifically on behavior? Should we focus specifically on mental processes? And some people vehemently disagreed with one side or the other. Now we really understand it's a unique combination of the two. Like we need to understand both in order to understand the full human experience. So, and here's kind of an example of what this might look like. If you were studying people who were attracted to each other, you could study the behavior of kissing. The observable behavior in this case would be the people actually kissing. If you're out and about and you see couples interacting and you see they're very, intimate with one another and they're kissing, that is a very observable act that you could witness and document, whatever you're studying, and then you also have maybe the mental processes that are happening below the surface, like why are they kissing? Maybe they're planning, they just got engaged and they made this big life plan, and you didn't necessarily know that, but you could observe the behavior and maybe talk to them afterwards and kind of figure out what's going on below the surface. So another aspect of psychology is we want to think in a scientific frame of mind or a psychological frame of mind. I think these are applicable to not just psychology, but really any kind of scientific endeavor. We want to be a critical thinker. You want to be open and curious. You want to be skeptical, obviously not too skeptical, but be willing to, not take things at face value and really be willing to look below the surface and look for the actual evidence before you decide, oh, I believe this or I don't believe that. And being objective, gaining knowledge from the actual data, not what we want to see, but what is actually there. So thinking about these different kind of processes, critical thinking, curiosity, skepticism, objectivity, think about, behavior and mental processes. Why would we want our thinking in this case to be critical? Maybe pause the video, write some ideas down and come back whenever you're ready. I think really it's just about being willing to, to take in all of the data, not just looking for the data that confirms or disconfirms your ideas, and not cherry picking things, but being open to possibilities that you never, expected before. And I think that's the whole goal of science, is to kind of break us out of, our own expectations, use the data, what's actually there to tell the story, not, whatever biases or hopes that we wish to embed in the story. So the psychological frame of mind, we want to derive truth based on evidence. We want to think critically because it leaves us, open to seeing unexpected results, possibly explaining counterintuitive results, things that maybe we had a hypothesis, but we're getting something that's completely different. And so science is driven by this empirical method, gathering data, using observable events, collecting data, and using logical inferences and reasoning to explain what we're seeing in the data. We want to be open and curious about the data, not locked in or rigid about what we hope to see, because then our results are biased and we may be cutting ourselves off completely. And so, one of the big kind of debates in psychology that even to this day still to some extent definitely exists is, thinking about the link between mind and body, this whole idea of dualism. I mean, this goes all the way back to like Descartes and philosophy and things that are outside of the purview of this course. Maybe if you take an intro to philosophy, you might be aware of some of these ideas, but, one of the first kind of psychologists to really explore this idea is Wilhelm Wundt. Wilhelm Wundt was a German scientist who was kind of the first person to develop a modern psychology laboratory. And this took place in Leipzig, Germany. And he studied mental processes, specifically how we experience stimuli, that connection between when we see or hear or feel a stimuli and then we react to it. He was really one of the first people to study reaction times. And he also explored elements of consciousness through his own kind of perspective on psychology called structuralism. And one of the big components of structuralism is the process of introspection, thinking within, going deep, thinking about oneself, or thinking about things that you're engaging in. So for example, my little fitness watch is going off. I better stop that. So introspection, you might ask a person, you might, give a person or show a person either in real life or a picture of a piece of chocolate cake. And you'd say, tell me about tell me what you see, and then tell me about what you experience. from what you're seeing. And the person would objectively tell you, oh, that's a piece of chocolate cake. Like, they're not going to look at the chocolate cake and say, oh, it's a mouse, you know, it's something completely different. There's an objective reality that I'm looking at a piece of chocolate cake. But they also have a subjective structure to their consciousness, to how they perceive the chocolate cake. Some people love chocolate cake and they're like, it's my favorite dessert and I would eat it every day if I could. Other people, maybe if you're allergic to chocolate or you're lactose intolerant or whatever reason, you know, maybe you're trying to avoid sweets, you say, oh, I hate chocolate cake. So people might have we have these objective sensations, the cake itself, and then we have the subjective experiences about the sensation. And that, according to Wundt, is the basic structures of the mind, that connection between body and mind. William James is the first American psychologist, and he was one of the first to kind of explore the purpose of the mind and also its role on behavior. And he developed a school of thought called functionalism, and it's kind of the early kind of it's the school of thought that led to the development of evolutionary psychology. So basically, what function does our mental processes and behaviors serve to allow us to adapt to our environment? There's very much an evolutionary component built in, built around Darwin's theory of natural selection. So we'll talk more about that, I think, in subsequent chapters. Those are just kind of some of the table setting folks that you need to be aware of. Now, as we move forward in time, we are at modern psychology. And, you know, some people think about psychology in terms of like treating mental illness. And that is a part of psychology. That is certainly true. But under the umbrella of psychology, scientifically studying mental behavior or mental processes and behavior, we have several different approaches we can use for studying those phenomena. There's a biological approach, a behavioral, psychodynamic, humanistic, cognitive, evolutionary, sociocultural. And most things under psychology will fall under one of these different approaches to psychology. And so that's kind of the framework we're going to use for the rest of this chapter and going forward in subsequent chapters. So the first thing to consider is the biological approach, and it's really looking at human behavior and mental processes from a biological standpoint. How does the physical, you know, the body itself, the brain and the nervous system, how do those things impact our behavior? And specifically, this has led to the development of neuroscience, which is specifically studying the nervous system and how it impacts human behavior, human thinking. And we will spend, I think, at least 3 chapters kind of exploring this topic in more detail. But looking at the structure, the function, the development, genetics, biochemistry of the brain, of the nervous system and all its various parts. We will explore this in more depth, I believe, in chapter 2. So this is really looking at a physical basis to explain behavior, to explain thinking, to explain emotions. And you might look at specific parts of the brain to explain those things. Whereas a behavioral approach is very focused on the half of that definition we talked about, observable events, behaviors, and looking at what role environmental determinants have on our observable behavior. What role does the environment you live in or grow up in play on the kinds of behaviors we might expect? So there's not a lot of explanation on thought. It's really focused specifically on behaviors. So if we have on one side, we have behaviors, on the other side, we have thoughts. The behaviorists are firmly entrenched on that left side. Some behaviors that we will talk about in subsequent chapters, John Watson, B.F. Skinner, I think they'll come up in chapter 5. The psychodynamic approach is where we introduce Sigmund Freud, and this is introducing the idea that there are parts of the mind, specifically the unconscious part of our mind, that influences how we think and how we behave, and we may not even be aware of it. Until we, go into therapy or we analyze our dreams or things like that. And it also puts a tremendous emphasis on childhood experiences and attempting to explain behavior. Childhood is very important. Freudians like Sigmund Freud and some of his followers also explored the development of sexual and aggressive impulses, especially starting early in childhood, and how we learn to kind of cope with and harness those impulses kind of determines the rest of development. So there's a picture of Freud, but there are plenty of others who followed in his footsteps who would be considered neo-Freudians. And he is the father of the school called psychoanalysis. We will talk about this man and psychoanalysis quite often in this course, almost like every other chapter, it seems like Freud comes up. The humanistic approach to psychology is a very optimistic approach, really looking at the positive qualities of human beings and how everyone is capable of growth, capable of becoming the best version of themselves. Everyone has free will, capable of making choices in their lives. And those choices, the choices we make are a huge influence on our development, specifically on our sense of self, which we'll talk about in a future chapter. There's also the cognitive approach, which is the antithesis to the behavioral approach. In this approach, we are only focusing on things that are happening between our ears, knowing, thinking, planning, deciding, dreaming. I mean, all of these things that would be considered cognitive events or events related to thinking. So memory, planning, problem solving, perceiving, dreaming. I think about half of our chapters in this course relate in some way to cognition. So we will talk about these ideas quite often. And the idea is our mind, especially the human mind, and really any mind in general, is very active. It is a very machine-like, is always processing data, learning from that data. So there's never really a dull or passive moment with the human mind. An evolutionary approach is looking at explaining human behavior from the standpoint of Darwinian natural selection. How have certain behaviors, ways of acting allowed us to adapt and to reproduce and continue the species? So certain qualities or behaviors that allow for the survival will be naturally selected to be passed on to subsequent generations, and behaviors that don't necessarily lead to reproduction, survival, thriving, things like that will eventually be weeded out. But we are talking about, from an evolutionary standpoint, we're talking about hundreds of thousands of years, if not even millions of years, depending on what we're trying to explore. And a lot of it can be somewhat speculative, but it is still a really interesting perspective. David Buss is a name that you should be familiar with. We will talk about evolutionary psychology again. This is just sort of an introduction. Another approach is the sociocultural approach, and this is looking at trying to explain human behaviors in terms of our social settings, the cultural groups we belong to. So maybe what schools we grew up in or go to, what families we grew up in, and looking at how those can explain differences in behavior, comparing, and you can use like exploring different cultural groups and how those have impacts across different behaviors, depending on what you're interested in studying. So maybe, I don't know, studying, eating habits from one culture to the next or one society to the next. It allows us to make comparisons across countries or within different groups of different countries. So it allows us to kind of understand the impact that culture has. And so within those different approaches, there are a number of different specializations anybody can take within, studying psychology. So, there are people, for example, who study mental health and helping people treat mental illness. And that would be kind of the clinical and counseling side of things. But we look at, so many other areas of areas of study, and this is not even an exhaustive list. My PhD comes from the educational psychology side of things. So I'm in this little block here, but other people, depending on what you study related to psychology, you will find yourself in a number of different specializations, perhaps. So regardless of what kind of perspective we're using, when we talk about psychology, it is a science. And now let's kind of explore that, what that means. Science is not just using beakers and test tubes and being in a laboratory. Those things are part of it, but it's definitely not what science is. Science is a method. It's a way of thinking. It's not necessarily what you study, but how you study it. There's a scientific method, or methods, really, actually. It should be plural. There's not just one single method, but those methods revolve around this idea of observing phenomena in your environment, hypothesizing maybe about what's happening about the relationship between variables, running some kind of test. And the gold standard usually is experimental research, but that's not the only way you can test a hypothesis. Gather your data, draw conclusions, and evaluate those conclusions. And depending on your results, you might go back to the drawing board and revise your hypothesis. But science is an iterative. It's an iterative process. It doesn't necessarily go 1, 2, 3, 4, 5, and you're done. You might go 1, 2, 3, 4, 5. Back to 2, revise your hypothesis, test it again, conclusions, evaluate. You might do this several times before you finally reach your conclusion. So Step one, observe some sort of phenomenon of interest. Ideally, it should be something that interests you. That's usually where things start off at. Out of curiosity, we notice something, we wonder, oh, why is this happening this way? But ultimately, you're talking about exploring the relationship between variables, between coronavirus, for example, quarantining and mental health. You might want to explore those variables. Why are people more depressed when they're quarantining? Why are people more, anxious? Things like that. Typically, you are using some sort of theory to kind of explore your questions. Theories are currently best, it's our current best explanation for trying to explain the relationship between two variables. Theories are not written in stone in the sense that they can't be changed. They definitely can change and evolve as more data, as more understanding happens. But theories are our best explanation. So, and that's different from a hypothesis. A hypothesis is how I predict something will happen between two variables. And a theory is an explanation that's usually built around confirming hypotheses, again and again and again. Ideally, we want our theory to be falsifiable. It shouldn't be something that can never be disproven. That's not really scientific. That's getting into things like, morality and philosophy, et cetera. So we develop a hypothesis, which again is our prediction, how we think the relationship between two events. It needs to be something that is predictable, something that is measurable, ideally derived from theory. In some cases, you might be developing your own theory, but more often than not, science is about standing on the shoulders of giants. You're using pre-existing theory to kind of as a lens to understand the phenomena, and then gathering data through empirical research, defining what variables are. We want to operationally define our variables, which means we're very specific about how we're measuring them. So when we say we're interested in anxiety, for example, what does that mean? What do you mean by anxiety? Does that mean somebody's going to take a questionnaire about how anxious they are? Does that mean you're going to measure their galvanic skin response? I mean, you have to be very clear about what you mean by your definition for your variables, so other people can read your research and understand, oh, okay, I see how they did this. You're going to analyze your data using statistical procedures, inferential, descriptive statistics, mean, median, mode, and it depends on what kind of data you're collecting. Once you've ran the data, you want to draw conclusions about what that data means, and ideally you want to write it up in a way that the results can be replicated, meaning somebody could read your results and conduct the same study, and that's great. That's how we know that your results are holding up. For example, if you conduct research and you get a result here, and somebody else reads your report and does the same research at another school or another laboratory, for example, and they get completely different results, then we have to start wondering about the theory, about the hypothesis. So replication is a huge part of science. It's okay to replicate. We're looking for reliability in the results. Are we getting consistent results? And then finally evaluate the theory. Do we need to change the theory? And ideally, this is where you share your results with other people in the form of peer review. You submit the paper to a journal or to a conference or something along those lines, and you get peers within the scientific field who read your research and decide, oh, hey, we think this is good. We think it adds to existing theory, or maybe we think you need to consider this, and then it gets published. I've done this several times as an educational psychologist, and this is the whole kind of safeguarding. You don't just let anybody publish anything. It goes through a very rigorous process that is not easy by any means, and it's meant to kind of safeguard. Like knowledge is, especially scientific knowledge, it's very precious and it's very important, and we want to make sure that we're not putting out bad knowledge, bad science. So, kind of within, that's the scientific method, and within kind of thinking about that in terms of psychological research, there are several different kinds of research in psychology. There is descriptive research, correlational, experimental, and we'll kind of break each one of those down. So descriptive research oftentimes is where you start with a research problem. This is your goal is simply to describe describe the phenomena as it is. You're not trying to necessarily explain any kind of relationships or manipulate anything. You're just simply saying, hey, I want to know about this. So for example, if you wanted to explore the phenomena of college students, working during the pandemic, from home, you wanted to just describe simply what's happening, or how many college students are now working from home now, or, something like that. You're just simply describing the phenomena. through observations. Maybe you give surveys or interviews. Maybe you collect case studies in terms of, a really unique group. Maybe that would kind of highlight the phenomena. Maybe you collect data from those individuals. But it's just about telling a story. What's going on with this particular phenomena. Case studies are a really cool way of doing so. This is where you use a really small group, maybe one person or even a handful of people who are all experiencing a certain phenomena. And you're using that to kind of tell the story. Instead of collecting data from a lot of people, you're really hyper focusing in on maybe a select group of people. It's very in depth. It's very rich in terms of the data you can get, the stories you can tell. And when I say story, I don't mean fictional. I'm not trying to say you're telling a fictional story. I mean just what is the data? What are we trying to say here with the data? And the problem is, though, you can tell a really cool story, but this is very hard to generalize. Like if you are trying to collect data about people's experience during the pandemic, and maybe you collect data from 5 different people who experienced this phenomena, that may not tell you much about how everybody else experience that phenomena. So this is a really cool way to get some rich data about something maybe that's new, but it doesn't give us the full scope of the picture by any means. So descriptive research, it doesn't answer questions about why things are the way they are, but it's a really good starting point. And for most research, it's where you start. Correlational research tends to be one of the next steps, or at least kind of how we think about the relationship between variables, is we want to start with correlational research. We want to know, one, is there a relationship between these two variables? And if so, how do they change in relation to one another? And mathematically and statistically, this is called a correlation coefficient. It's described as R, lowercase r. It's measured between -1 and +1, with 0 being in the middle. And we're using that number to determine the strength or magnitude of the relationship. So the closer the value is to -1 or +1, we would say it's stronger. The closer it is to 0, the weaker the relationship is. So 0 is saying not much is going on there, no relationship. 0.25 typically is saying there's a weak relationship. 0.5, moderate, like there's something going on there. 0.75 is considered strong. 1 is considered, anything above that, very strong. So if you got a correlation of 1, you're saying every time this changes, every time X changes, so does Y. And it's more like a straight line graph. Would be considered a perfect correlation, but that's extremely rare in the human sciences, or the social sciences, excuse me. So a positive correlation, positive correlation means when X goes up, so does Y. When one variable increases, so do the other. So for example, the longer the lecture goes on, the more yawns. So we can see those data points, kind of short lectures here, few yawns, long lectures here, many yawns. And that's how our data. Positive means we can actually draw this straight line through. We can see the line. It's clustering around this line. So negative correlation would be the opposite. As one variable goes up, the other decreases. So the longer the lecture goes on, the lower the student's attentiveness. Your attention tends to drop the longer it goes on. And the line actually kind of fills out going the opposite direction. Looks like this. We can draw the line through the data and see the fit. So factors vary in the same direction for positive, factors vary in opposite direction for negative correlation. But correlation tells us about the existence of relationships, but it does not tell us more than that. It does not tell us, does X cause Y? We cannot derive causation from correlation. So for example, why is parental harshness correlated with child rebellion? We can't say that. We can say that they're related to one another, but we don't necessarily know why. It could be that harsh parents drive their kids to rebellion. Could be rebellious kids drive their parents to be more harsh. It could also be in stressed out families, both parents and kids are at their worst. Argumentative families, more genetically predisposed to such behaviors. Other possibilities. So it does not tell us what way the relationship is going. It just says, hey, there's something here, but we really have to explore it further if we want to know, about the more specific details of this relationship. So it doesn't necessarily settle the why. It just says, hey, there's a relationship. It does not tell us much more than that. Could be a third variable, could be some other combination. Could be a number of factors, perhaps. Why is a happy mood correlated with sociability? Being with others lifts our spirits. happy people seek out company, demands of working, et cetera, et cetera. All of these are possible explanations. And it just shows like these things are related, but we need to understand it. We need to dig deeper if we want to derive some kind of causation. And that's where we use experimental research. Experimental research gives us the tools to determine causation. Ideally, we have different groups. We have an experimental group and a control group. The experimental group receives the treatment. The control group does not. They're used as a baseline of comparison, but we want to make sure people are randomly assigned to those groups. We don't want all males in the experimental group, all females in the control, or all sophomores in one group. We want to make sure everybody who's in the study has an equal chance of being in either group. So, we, in the experimental group, we're going to manipulate our independent variables. So what we think, so for example, if we wanted to look at like depression scores and an antidepressant medication, we could manipulate whether or not somebody gets an antidepressant medication or they get a placebo, or we can manipulate how much they get, 5 milligrams, 10 milligrams, 50, whatever we're trying to look at. That's the independent variable. The control group is treated equally. They're not given any kind of manipulation. So maybe in this case, they don't get any medication. We just want to just see how they improve normally. And this allows us to compare. We can look at the differences between these two groups and really see, okay, are the differences attributable to the medication or the treatment we're using, or what's going on there? And we're using a dependent variable to measure. That's what we're trying to measure. So independent variable is what we manipulate or change across groups. Dependent variable is what we actually measure. You might have a within participant design. So you can have some cases where participants will serve as their own control group. So maybe you have them receive that, you measure them before they receive the treatment, you measure them after they receive the treatment, and you do a pre-post comparison. You have participants in all groups where they're in the control and the experimental group. You have quasi-experimental designs, maybe, and this is you have to explain why you want to do these things when you're writing up your research, but maybe there's a reason why you can't randomly assign people to certain groups. Like I think about in education sometimes, like as a teacher, when I'm doing research in education, I can't just like randomly assign people to different classes. A lot of times it's like, well, I have this class that's already set and I have this class that's already set. So I can't just mix and match those students. As great as that would be for science, that's just not practically how it works. So some cases you might have quasi-experimental design. But either way, trying to determine some level of causation, and experimental design is one of the few that actually allows us to be able to look at why something is happening, exploring cause and effect, because we can manipulate variables. We can control for certain variables, we can manipulate others, and really explore, okay, is this why this relationship is happening? If it's not, we go back to the drawing board and try again. Some other concerns related to psychology, especially in science, we are really concerned with validity, meaning like when we collect data and we write up our results, like, are we making good inferences based on those results? So external validity means like, are we actually measuring this? Is this representative of a real world issue? Like, are we measuring what we actually intend to measure? Do these results apply to the real world? Do they generalize, or are they just related to these folks who were in our research? We also want to make sure we have independent or internal validity, Are these related to the actual variable manipulation? Are changes happening due to bias, any possible logical errors? I mean, these are things that you can explore statistically and otherwise in your research, but you want to be aware of. And the idea behind this kind of rigorous approach to science is to avoid bias. We want to try as much as we can. Humans are biased. We're flawed. We definitely, it's hard to keep our bias out of things, but we have to try our best to do that. And one of those is called experimenter bias. And when people understand, or they have certain expectations, like, oh, I'm in this research and I need to behave in a certain way, the same thing can also happen with researchers. If they're aware, for example, of who's in what condition, they might treat people in one condition differently. Maybe sometimes it's subtle, maybe sometimes it's not, maybe it's unconscious or consciously. But if we can create conditions that remove the potential for bias, that is ideal. So you might use things like the placebo effect, where some people receive a treatment, others receive a placebo form of the treatment. A lot of times you see that in medication research. We want to make sure, are people actually improving because of the medication, or are they improving because they think they will? Another example of how we can kind of rule out bias or try to prevent bias is through blind experiments. A blind experiment, a double-blind experiment, means the participant and the researcher are not aware of what condition they're in. So if you're giving, you have a placebo group and a medication group, we don't want the researcher or the participant acting differently if they knew what group they were in. So for example, like if you're a participant and you knew, oh, I'm getting this sugar pill, this placebo, like you would probably just you would act completely different than versus, oh, I think I'm actually getting an antidepressant, an anti-anxiety medication, whatever. It prevents you from changing your behavior, biasing your behavior. And the same thing for the researcher. If they think, I don't know if this person took the drug or if they took the placebo, they're going to treat everybody the same versus kind of being biased one way or the other. And again, the point of experimental research is you follow these certain steps, you write up those steps as clearly and concisely as possible, because you ideally would like that research to be replicated in some way. And ideally, the larger your sample sizes, meaning the larger the group of people you study from the overall population, it's good. The more people you use in your research, the better. It means your results tend to hold more water the larger your sample size is. And also, we want to share those results and share how we went through getting those results to be transparent and allow the scientific community to digest the information and replicate the research or ask questions or probe and the theory and all these different things that are intended to advance science, advance theory. Here's what research, what it kind of looks like in application. So descriptive research is determining just the basic dimensions of a phenomena. Here's what it is. What does it look like? Correlational looks at how variables relate and change together. And experimental research looks at whether or not there's a cause and effect. And typically you're kind of following in a footsteps. You might start with descriptive research. Once you understand the phenomena more, you might develop and kind of conduct more, research where you can explore the variables in more depth and then actually begin to manipulate variables. And each one has its strengths and weaknesses. I mean, no form of research is perfect. We talk about conducting research. We are ideally, we're trying to understand a population, which is an entire group. But for time, for money, all kinds of reasons, we cannot collect data from every single person in a population. So for example, I teach at OSU OKC. If I wanted to understand people's attitudes about, the new kind of Canvas updates and how how it relates to their learning, it would be ideal. It'd be great if I could survey or interview every single person who's using this technology, but that's just not going to happen. That's too costly, too time, it just wouldn't make sense time-wise. So instead, we might want to use a sample, which is a representation of that population. So instead of surveying or interviewing all, 10,000 students on campus, maybe you interview or maybe you survey only 100 of them, depending on, what kind of information you're trying to collect. So you're trying to derive inferences about a population from a sample, and statistical techniques allow us to do that. And ideally, we do want the sample to be representative, meaning it matches like the actual population. So for example, like if the overall population has a breakdown of like 55% females and 45% males, we probably want our sample to look like that too. We don't want a sample that's like 95% males and 5% females, because that would probably lead us to some very biased results. The closer our sample looks like our population, the better. Also, when we are assigning people to groups based on that population, we want to use random sampling. That means everybody in the population has an equal chance of being selected. So at OSU OKC, that means whether you're a female, whether you're a sophomore, whether you're a concurrent student, whether you're Black or white or any of these things, you all have an equal chance. We're not just selecting only female nursing majors who are in their sophomore, it's just, you want that to be random to keep it more in line with what the population looks like. And psychologists conduct research in a number of settings. You might create an artificial world, otherwise known as a laboratory setting, where you have much more control. You can manipulate variables and really explore the relationship between those two variables. Some psychologists might actually go out into the real world and collect data in a more natural setting. One of the most common ways of doing so is called naturalistic observation. It's where you watch, not in a creepy way, you watch people interact in their natural environment. And if people don't know they're being watched, they tend to behave, as they would. But people do know, if they do know they're being watched, they'll certainly change their behaviors. So there are certain advantages to both. I mean, you have more control over an artificial kind of laboratory setting. But you get people, they might change their behaviors because they know they're in a laboratory setting being watched, versus in a real world setting, you have no control, but maybe you can see how people actually react, So that's kind of, now we're kind of wrapping things up, and now one kind of last thing to consider is the ethics involved in conducting research. I mean, participants in any research study have rights. Those are determined by the American Psychological Association. They have to be given informed consent to the best of their ability, told about what they're going to be doing in the research, and told at any point you can withdraw from the study. You're not bound to continue just because you signed a consent form. Also confidentiality, meaning whatever information you provide is going to be confidential and possibly aggregated. And instead of being looked at individually, you're just looking at the whole rather than each individual piece. And then debriefing. Once the study is over, a lot of times you inform participants about, hey, this is what's going on in the study, especially if you use things like deception. Sometimes you have to conceal the entirety of the study, or you have to conceal details. So that gives you a chance to basically come clean and say, hey, we didn't tell you the exact truth here, but here's why. And then any study, especially when we're talking about using human participants, has to go through an IRB, or an institutional review board. This is what happened. OSU OKC has one, institutions have them, and it's a long application process where you have to go through and explain your research and what you're going to do and justify, if you're going to use deception, you have to justify it. You have to include your informed consent document and all these important ways, saying, hey, I'm going to treat my participants ethically. So, and that kind of raises questions that should psychologists take stands on issues about which they have expertise? There's really no right or wrong answer to that necessarily. So that's something maybe kind of consider for yourself. And if you'd like, pause the video and stop and think about that. Animals also have rights as well. We want to make sure that animals are, a lot of times, to understand human phenomena related to human, we might study non-humans. It's not as common maybe as you might think. Really only about 5% of researchers, and a lot of times you're using rats and mice in that case. But the idea is, we want to treat these animals with dignity, housing them, feeding them properly, making sure maintaining their psychological and physical well-being. Any harm that is done has to be justified. You can't just be cruel and mean to animals for the sake of, being cruel and mean. You have to have any kind of justification where there is any sign of potential harm or psychological or physical has to be completely justified. And those, the conditions in which, animals are kept, are you have to document that. You might have inspections, things like that. So you want to make sure things are on the up and up. So last thing, think about how can I use psychology in my life? I think as a consumer, try to apply this critical thinking, this thinking like a psychologist in your everyday experience, especially as a consumer. I mean, we are bombarded with advertisements and messages from politicians, from products, from all kinds of things, trying to take our attention, trying to take our money, trying to take our time, our resources, and we need to be more discerning, more skeptical about where we put our money, where we put our time, put our resources. So I think kind of adopting this kind of skeptical mentality in your own life means avoid overgeneralizing results. Be cautious when you're applying group results to individual experiences. Look for conversions of evidence. Like, every single study ever done in science has some flaws to some extent. Like, for example, you could read any single paper on climate change and there will be individual flaws in those papers. Like, because we're talking about humans, we're talking about collecting data as humans. We are prone to error. It happens in our science too. But when we talk about a convergence of evidence, when you have hundreds of thousands of papers saying the same thing, even if each one of those are individually flawed, that convergence of evidence is a pretty big deal. So yes, that's something to be more considerate of. Don't just look for one piece of evidence and go with it. Look for multiple pieces of evidence. Question causal inferences, especially when really maybe you're only dealing with correlation. Consider the source. Some sources are obviously better than others. And, I think applying it not just in consumer research. I mean, you can apply these ideas in your everyday life, the goals you set for yourself. I think you can use the materials and use the things you're going to learn in this class and how to think like a psychologist to ultimately make your life more positive, being more mentally and physically healthier, and just overall being happier. I mean, I'm not saying psychology is the answer to all our questions or problems, but I think there are some really powerful tools that can be used to help you. So anyways, that's where we're going to stop here. That's chapter 1 of the King book. We're going to jump back in pretty soon for chapter 2. So let me know if you have any questions. Otherwise, I'll see you on the other side for chapter 2. Stop recording. Peace.